Which statement best describes isotonic regression in scikit-learn? A. A linear regression model that forces the predicted values to be monotonically increasing. B. A method that adjusts predictions to ensure they follow a monotonic trend, either increasing or decreasing based on the input features. C. A technique that transforms target values to enforce a monotonic relationship with the input features. D. All of the above. Incorrect. While isotonic regression involves enforcing monotonicity, it's not strictly limited to linear models. It can work with various types of models, including nonlinear ones. It aims to adjust the predictions to follow a monotonic trend, not force a specific type of model like linear regression. Correct. This accurately describes isotonic regression. It takes existing predictions and adjusts them to ensure they follow a consistent trend, either increasing or decreasing based on the input features. This ensures the model's predictions are in line with expected relationships between the input features and the target variable. Correct. This statement is also correct. Isotonic regression essentially transforms the target value's predictions to enforce a monotonic relationship. This transformation doesn't change the input features but ensures the predictions are consistent with the expected monotonic trend. Correct. As options B and C accurately describe isotonic regression, and option A is a partial description, isotonic regression can be applied to linear models. Option D is the most accurate and comprehensive answer. D. All of the above. A monotonic relationship means that as one variable increases, the other either consistently increases, monotonically increasing, or consistently decreases, monotonically decreasing. In credit scoring, it's expected that a higher credit score should correspond to a lower predicted default probability. A monotonic decreasing relationship. When predicting house prices, we generally expect that higher square footage or better quality features should correspond to higher prices, a monotonic increasing relationship. Consider a set of exam scores X and corresponding grades Y. A monotonic increasing relationship would mean that as the exam score increases, the grade also always increases. For example, if X 60, 70, 80, 90 and Y C, B, A, this represents a monotonic increasing relationship. A technique that enforces monotonicity on a set of predictions, ensuring that the predicted values follow a consistent trend, either increasing or decreasing based on the input features. Isotonic regression can be used to adjust predictions of default probabilities based on credit scores to ensure that the relationship between credit score and default probability remains monotonic. In medical diagnosis, isotonic regression can help to ensure that predictions of the likelihood of a specific disease based on symptom severity maintain a monotonic relationship, meaning higher symptom severity always corresponds to a higher likelihood of the disease. The code snippet below demonstrates isotonic regression using scikit-learn's isotonic regression class. Python. From sklearn, isotonic import isotonic regression. Import numpy is np, x np, array 1, 2, 3, 4, 5 input features, y np, array 1, 2, 1, 3, 2 original predictions. Model isotonic regression. Model, FitX, YPRED model, PredictX monotonically adjusted predictions. Printipred. What does the sklearn, isotonic, check increasing function do? A. Checks if a given array is strictly increasing. B. Determines if an array's values are non-decreasing. C. Verifies if an array is decreasing or constant. D. All of the above. This statement is correct. The check increasing function verifies if an array is strictly increasing. A strictly increasing array means each element is greater than the one before it. This function would return true for arrays like 1, 2, 3, 4, 5. Strictly increasing every element is greater than the one before it. This statement is also correct. The check increasing function can identify if an array is non-decreasing monotonic. A non-decreasing array allows for elements to be equal to or greater than the previous element. So, 1, 2, 2, 4, 5 would be considered non-decreasing and the function would return true. Non-decreasing monotonic, every element is greater than or equal to the one before it. This statement is correct as well. Check increasing can also determine if an array is decreasing or constant. This means that each element is less than or equal to the preceding element. For example, 5, 4, 3, 2, 1 is decreasing, and 3, 3, 3, 3, 3 is constant. Both would result in true when passed to the function. Decreasing or constant, every element is less than or equal to the one before it. This choice is the correct answer. The check increasing function is designed to check for all three scenarios: strictly increasing, non-decreasing, and decreasing or constant. Answer D, all of the above. D, all of the above. Isotonic regression is a type of regression that ensures a monotonic relationship between the input features and the target variable. This means that the relationship is either always increasing, always decreasing, or constant. It's useful in situations where you expect a trend in the data. Modeling the relationship between age and income, where you would expect income to generally increase with age. Predicting ice cream sales based on temperature, where sales would likely increase as temperature rises. Monotonicity refers to the property of a function where its output always increases or always decreases as the input increases. This property is crucial in many applications, ensuring that the relationship between input and output remains consistent. Ensuring fair lending practices, where a loan interest rate should not increase as a borrower's credit score improves. Modeling the effect of fertilizer on crop yield, where you would expect yield to increase as the amount of fertilizer applied increases. The check increasing function and the concept of monotonicity have various applications across different fields. Modeling relationships between variables where a trend is expected, e.g., age vs. income, temperature vs. ice cream sales. Correcting data errors or inconsistencies that violate monotonicity. Ensuring ethical implications in decision-making systems, e.g., preventing discrimination based on age, race, etc. Let's consider the following array: 2, 4, 5, 6, 8. This array is strictly increasing because each element is greater than the one before it. If we use the check increasing function, it would return true, confirming this property. However, if we had an array like 2, 4, 4, 6, 8, it would be non-decreasing monotonic. As the third element is equal to the second element, the function would still return true because it recognizes both strictly increasing and non-decreasing patterns. You are tasked with building a model that predicts the price of a product based on its features. However, you know that the price should always increase as the product's quality rating goes up. Which sklearn tool would be most suitable for this task? A. Linear regression. B. Decision tree regressor. C. Random forest regressor. D. Isotonic regression. Linear regression doesn't inherently enforce monotonicity. It can produce a linear relationship, but the slope might not always be positive. leading to predictions where price decreases as quality increases. It's not the best choice for this task. A. Linear regression. Decision tree regressor, while capable of capturing nonlinear relationships, doesn't guarantee monotonicity in predictions. It could produce splits where higher quality ratings lead to lower prices, contradicting the requirement. B. Decision tree regressor. Random forest regressor, being an ensemble of decision trees, inherits the same potential issue as decision tree regressor. It doesn't intrinsically enforce monotonicity, so its predictions might not adhere to the desired trend. C. Random forest regressor. Isotonic regression is designed specifically to enforce monotonicity in predictions. It ensures that as the input feature quality rating increases, the predicted price also increases, fulfilling the requirement of the problem. D. Isotonic regression. D. Isotonic regression. A function exhibits monotonicity if it always either increases or decreases as its input increases. In our case, the price of a product should always increase as the quality rating goes up. Example: a product with a higher quality rating should always have a price that is greater than or equal to a product with a lower quality rating. Monotonicity. Isotonic regression is a non-parametric technique that explicitly enforces monotonicity in its predictions. It adjusts the predictions to maintain a monotonic relationship between the input feature and a output prediction. Isotonic regression. 1. Pricing models ensuring prices increase with product quality. 2. Credit scoring predicting creditworthiness based on income, with higher income leading to better scores. 3. Medical diagnosis modeling disease severity based on test results, where higher values indicate greater severity. 4. Performance prediction estimating employee performance based on experience, with more experience leading to higher performance. 5. Calibration of probabilistic models adjusting probabilities to adhere to monotonicity constraints. Use cases. The isotonic regression class in scikit-learn provides an implementation of the isotonic regression algorithm. It allows you to enforce monotonicity in your predictions, ensuring that the predictions are consistent with your domain knowledge. Sklearn's isotonic regression. Let's say we have the following data. Quality rating price. -- 110, 212, 315, 418, 520. Using isotonic regression, we can enforce the monotonicity constraint, ensuring that the predicted price always increases as the quality rating goes up. D. Isotonic regression.